There has been a lot of talk about AI lately, and it seems like everyone is talking about how amazing it is or how scary it is. If you ask someone to explain it, they might say something like this: "I'm not sure that really helps us understand what AI is." So let me try to explain it another way. Let's get down. AI, artificial intelligence, is basically technologies trying to mimic human intelligence. And while we don't exactly have a good grasp of human intelligence ourselves, we do know some things about it. For example, one thing we know is that human intelligence is generally based on knowledge. The more knowledgeable you are, the smarter you are. At least, that is usually the case, unless you have some kind of brain disorder, where you might be very smart, but just not apply your knowledge in an appropriate manner. In other words, if you were to make a list of everything you know, the longer the list is, the smarter you are. This makes sense, and it's pretty easy to measure. But where does knowledge come from? Well, it comes from experiences. Experiences turn into memories, which then become part of your knowledge base to use in the future. But this creates a problem for computers, because computers can't really experience things. They can collect data, which is basically digital records of experiences, but they can't actually experience anything themselves. To get around this, programmers have to input their own knowledge directly into the computer, essentially hard-coding everything they know about the world into the software. The more experienced the programmers are, the more knowledge they can put into the software. So in theory, you can create a very knowledgeable piece of software and thus very smart. That's kind of how old chatbots work. Programmers put in all this information about the world and how language works and how to respond to certain prompts. They even write out potential responses for certain questions. And that's how companies like ChatGPT built their products. Basically, they hired a bunch of people to sit there and write out tons of responses to questions and statements. And these days, instead of writing out responses manually, they use other software to generate responses automatically. It's still based on the same kind of pre-programmed rules and information. It's just a little more automatic than before. The idea is that once you've created software that's really knowledgeable, it can use that knowledge to make decisions. In fact, one of the main benefits of this kind of system is that it can make decisions faster than a human can. With a human, you have to wait for them to think about a problem and then come up with a solution. But a computer can go through lots of different solutions much faster than a human can. So, in areas like finance, this can be extremely useful. You want to get the best deal on a stock transaction done as fast as possible so that you can maximize your profits. There isn't time to wait for a human trader to figure out what to do. So that SY programs are developed that can quickly scan markets and execute trades at the best prices. In theory, this kind of system would only ever do what it was programmed to do. But, in practice, sometimes it would make a decision that wasn't coded in directly. For example, if a program was tasked with hiring employees for a company, and it was given all kinds of demographic data about the applicants, it might start to decide not to hire women or minorities, even though it was never programmed to discriminate. It would see that men and white people were being hired more than women and minorities, and decide to follow that trend because it seems to be working for the company. We saw this happen with a program used by Amazon to sift through resumes for job applicants. The program was supposed to help reduce bias during the hiring process, but it ended up discriminating against women. Ultimately, Amazon shut down the program. But this just goes to show that even though AI can be programmed with all kinds of bias detection tools, it doesn't always stop them from developing biases themselves. But regardless, there's no doubt that computers can be very smart in certain areas. They're great at following directions, doing complex calculations and making decisions really quickly. But when it comes to thinking outside the box, computers are not very smart at all. A computer can't invent new technology. It can't create new art. It can't come up with new ideas for businesses. It can only do what it's programmed to do. Computers can be smart, but they're not intelligent. So now, let us take a look at some of the inventions and discoveries that laid the groundwork for modern AI. Some experts trace the history of AI all the way back to ancient Greece around 350 BC. That's when the philosopher Aristotle developed the syllogism, a type of logical argument that uses deductive reasoning. It follows this form: all humans are mortal. Socrates is a human. Therefore, Socrates is mortal. The idea was that with enough syllogisms, you could reach any conclusion based on any set of facts. This is essentially how AI works today. Programs make conclusions based on the information they're fed. But back then, the concept was philosophical rather than technological. The modern concept of AI started to take shape in the mid-1900s, when computer scientists began to explore the idea of machines that could think like humans. One of the first people to seriously study the possibility of AI was Alan Turing. He's best known for his work breaking the Nazi Enigma code during World War II, but he also wrote one of the first papers on the subject of AI. In 1950, he proposed the famous Turing test as a way to determine whether a machine could be said to be thinking. Basically, he imagined a scenario where a human would interact with both a person and a machine, and then try to figure out which one was the machine. If the machine was able to convincingly imitate the human, then it passed the test. This basically meant that if the machine could hold a conversation and respond appropriately, then it was intelligent. In other words, the Turing test was a way to measure whether a machine could think like a human. Around the same time, other researchers were making progress in understanding how the human brain works. In 1943, the neurophysiologist Warren McCulloch and the logician Walter Pitts published a paper showing that a brain made of artificial neurons could perform any logical calculation. In 1956, a group of researchers at Dartmouth College, led by John McCarthy, held a workshop to discuss the idea of creating a machine that could think. Participants included some of the most brilliant minds in computer science, mathematics, and philosophy, including Marvin Minsky, Claude Shannon, and Nathaniel Rochester. By the end of the workshop, the researchers had agreed on a definition of AI and decided to call it the study of making machines that think. In the years that followed, AI research made some impressive progress. In 1959, Arthur Samuel created a checkers playing program that was able to learn and improve its game over time. This was one of the earliest examples of a machine that could learn from experience. In the early 1960s, researchers at Midsay iLab created a program called ELIZA that could carry on conversations with humans. ELIZA was one of the first chatbots, and it demonstrated the potential for computers to understand and respond to natural language. But as the decades went on, progress in AI research slowed down. Many of the early AI programs were rule-based systems that relied on large amounts of hand-coded knowledge. As the complexity of tasks increased, it became harder and harder to create systems that could handle them. For example, in the 1970s, researchers created a program called Dendril that could identify organic molecules based on their mass spectra. The program was able to learn from data and identify new molecules that it had never seen before. But it required a huge amount of computing power, and it was limited to a very specific task. This led to a period of time known as the AI winter, when funding for AI research dried up. But in the late 1990s, interest in AI began to grow again. This was due in part to the development of new machine learning algorithms that allowed programs to learn from data without being explicitly programmed. Machine learning has been a major breakthrough for AI. It has enabled programs to perform tasks that were previously thought to be impossible for machines, such as recognizing faces in photographs, understanding natural language, and playing games like chess and Go. One of the most popular machine learning algorithms is called deep learning. Deep learning uses artificial neural networks, which are inspired by the structure of the human brain, to learn from data. In recent years, deep learning has achieved state-of-the-art results in many areas, including image recognition, speech recognition, and natural language processing. So those are some of the key moments in the history of AI, from the early philosophical musings of the Greeks to the modern machine learning algorithms that are driving today's AI revolution. AI has come a long way in a short period of time, and it will be interesting to see where it goes in the future. Now check out some of our other videos about AI. Why is AI dangerous? Or watch the AI Takeover Explained. Or click this other link. Hey, thanks for watching.